Okay, welcome back to another video on the Math channel. It's your teacher, Mr. Lim here, and in this video, we are going to be looking at simultaneous equations as models. So by the end of this lesson, you'll be able to do these four things: understand the purpose of simultaneous equations as models, how to graph equations you might see in a worded problem, solve worded problems using simultaneous equations, and sketch the graphs of worded problems. So let's have a look at the first one. The purpose of simultaneous equations as models. So simultaneous equation models use two linear functions to describe a practical situation, and the point of intersection is often the solution to a problem. So the whole purpose of this is to find a solution to a problem. Here we have an example of a business called Are You Comfy Cushions. So what we have here is that the blue line is the revenue, how much money they get depending on how many cushions they sell. And this red line here is the cost, how much it costs to make those cushions that they sell. Okay, so we've got two functions, or two lines. And the point of intersection here is right there, which says that the company Are You Comfy Cushions need to sell 30 cushions in order to break even. Okay, and therefore, what that means is it cost them $300 to make those 30 cushions, and they also received $300 when they sold those 30 cushions, which means they made no profit or loss, and that's the break-even point. Okay. So how might you graph equations that you could see in a worded problem? So here we have the following graphs. X plus y is equal to 50. So most of these graphs will look something like this. Okay. So here x plus y is equal to 50. Well, if x, let's label this x and this one y. If x was 0, y would be 50, because 0 plus 50 is 50. However, if y was 0, x would have to be 50. So if y was 0, x would have to be 50. 50 plus 0 is 50. And so from there we can draw a straight line, and that line is x plus y is equal to 50. Alright. I'm going to do B with you, and then I want you to have a go with C. So question B, we've got A plus B is equal to 35. Just imagine it means the number of apples plus the number of bananas is equal to 35. There's 35 fruit altogether. So let's have this as our bananas, and these are as our apples, or A and B. If there were no apples, how many bananas would there be? There'd have to be 35. But if there were no bananas, there'd have to be 35 apples. Okay? And then you just draw your straight line. Alright, pause the video and have a go with question C. And when you're ready to check your answer, continue playing the video. Okay, so here, let's say for example, we've got an English mark and a maths mark, and when we add them together, we get 100 marks in total. Well, I'm going to start off with a graph. We'll have English here, maths here, it doesn't really matter which one. If you got 0 in English, you must have gotten 100 in maths. But if you got 0 in maths, you must have gotten 100 in English. So we've got everything we need to draw our straight line. Okay. What about question D? Here we've got I is equal to 20n. Maybe for something like this, you might want to choose to do a table of values. So let's do a table of values, N and I. The income earned depends on the number of goods sold. So I always like to use 0 and 1. If you sold nothing, your income would be nothing. If you sold one item, the income would be 20 times 1, which is 20. 2 points is enough to draw our line. So 0, 0, 1, 20, and we can draw a straight line. I'll get you to pause the video, have a go with E and F. When you're ready to check your answers, continue playing the video. Okay, welcome back. So I'm going to go through these answers now. Let's do a table of values. N and I, 0 and 1, 0, 1500. So here we have N, here we have I, 0, 0, 1, 1500. Draw a straight line. Okay, I should have also labeled this one. That's N and that's I. Okay, and last one. N, I, 0 and 1, 0 and 12.5. That's it. Okay, let's have a look at G, H, and I. I'll go through G, and then you can pause the video, have a go with H and I yourselves. Okay, so again, N and C this time. C is the dependent variable, okay, because the cost depends on the number of goods sold. So I'm just going to use 0 and 1 again. If N is equal to 0, this will become 0 plus 36 is 36. If N is equal to 1, then this will become 8 times 1, which is 8, plus 36 is 44. C for cost. We have 0, 1. Well, we can have 2, 3, 4. Actually, let's see. Let's go up by 5s. 5, 10, 15. Let's go up by 10. 10, 20, 30, 40, and 50. So 0, 36 is about here, and 144 is about there. Okay, when you're actually graphing this, try and be as accurate as you can. Alright, pause the video, have a go with question H and I yourselves. Okay, so we've got N and C, 0 and 1. If you sold nothing, it would cost you 3,500 to make. Okay, if you sold one item, 800 times 1, 800 plus 3,500 is 4,300. So when we graph this, we'll go up by 1,000. Actually, yeah, let's go up by 1,000. Okay, so we start at 3,500. And 4,300 is about there. Just make sure it goes through that line. Alright. And question I. And I. Sorry, not I. It's not income, it's cost. If nothing was sold, it will cost 285. And if one item was sold, it will cost 290. So might be best to go up by, so we've got 0 and 1. We can just call this one 285 and this one 290. Let's just do that. I know it's not to scale, but for a line graph it doesn't really matter. Okay, so now you should be able to draw graphs that we might see in worded problems. So when we solve worded problems using simultaneous equations, often a worded problem might ask you to find a break-even point. So I'm going to practice finding the break-even point algebraically. Okay, so the break-even point just means you need to work out how many products need to be sold in order for the business to not make a profit or a loss. What that means is that the break-even point is when revenue equals costs. So here, if the revenue or income is equal to 20N and the cost is equal to 8N plus 36, the break-even point is when income is equal to costs, or when 20N is equal to 8N plus 36. Now we can just solve algebraically. So I'm going to minus 8N from both sides. That leaves me with 12N is equal to 36, and therefore N is equal to 3. What that means is that you need to sell 3 of the products in order to break even. Okay, so I'll do one more with you, then you can try to see by yourselves. To break even, the income is equal to cost. So if income is equal to 1500N and cost is 800N plus 3500, we can now solve for the number of products that need to be sold. 1500N minus 800N is 700N is equal to 3500. Divide both sides by 700. N is equal to 5. That means you need to sell 5 products. And last one, I'll get you to pause the video, and when you're ready, check your answer. Okay, so to break even, the income must be equal to the cost. So 12.5N is equal to 285 plus 5N. I'm going to minus 5N from both sides, so that leaves me 7.5N is equal to 285. And now I can divide both sides by 7.5. And 285 divided by 7.5 is 38. 38 goods need to be sold. Okay, so let's see if we can apply everything that we've learned so far in this video to some worded problems. Okay, we're going to learn how to sketch these graphs. So Lauren's mathematics mark exceeded her English mark by 15. She scored a total of 145 for both tests. Find Lauren's marks in each subject by plotting intersecting graphs. To be honest, I actually find it a lot easier to just work it out algebraically and then graph that, rather than graphing it, because we don't know how big our graph needs to be, or what distance to place between each of the markers. So I prefer to just solve it algebraically. So her maths mark is equal to whatever she got for English plus 15. she scored a total of 145 for both tests. So that means whatever she got for maths plus whatever she got for English is equal to 145. And so here we've got simultaneous equations. We've learnt from last lesson how to do this algebraically. Because I have m as a subject, all I'm going to do is I'm going to substitute e plus 15 into what m is in the other equation. So technically this reads e plus 15 plus e is equal to 145. Or 2e plus 15 is equal to 145. 2e is equal to 130. So her English mark has to be 65. No, she got 65 for English. What did she get for maths? Well, maths is equal to whatever she got for English plus 15. 65 plus 15, 80. Okay, so now that we've done that, we can plot this on the graph. Let's have English here and maths here. So we have a look at the second. Let's have a look at the second equation. How do we graph this? Well, if she got 0 in maths, she would have gotten 145 in English. If she got 0 in English, she would have gotten 145 in maths. Okay, so of course when you do this, you need to be as accurate as possible. Okay, and for maths, she got, for the first equation, maths is equal to whatever she got for English plus 15. So if she got 0 for English, her maths mark would have been 15. If she got, let's say if she got 145 for English, then her maths mark would be 160. Alright, let's just say 160 is over here. And so now we can just plot that line. And we'll see here that if we were to do this accurately, that is the what she got for English and what she got for maths. So we had written this out or sketched this completely accurately. This number here would be 65 for English. This number here would be 80 for maths. Okay, but like I said, I find it best to just solve this algebraically and then graph it, if the question asks us to graph. Alright, question B. Charlie buys and sells books. Income received by selling a book is calculated using the formula I is equal to 16n. What that means is that she sells each book for $16. Costs associated in selling a book are calculated using the formula C is equal to 8n plus 24. Draw the graph of I equals 16n and C equals 8n plus 24 on the same number plane. Meaning that we will eventually have to find a break-even point. So let's just solve this algebraically. We know that a break-even point is when the income is equal to the cost. Well, here income is 16n. Cost is 8n plus 24. So subtract 8n from both sides. 8n is equal to 24. N is equal to 3. She needs to sell 3 books in order to break even. So that means when we draw our graph, one, two, three. Let's just go one more, 4. because we know she's just going to pass that. How much would she earn if she sold 3 books? Well, because the income is equal to 16N, if she sold 3 books, it'll be 16 times 3. Her income will be $48. So using that might help us to know where to go, or how far to go. So I'm just going to say this is 16, 32, 48, and 16 times 4 is 64. So I know it's going to go through here. If she sold nothing, she'll get nothing. So that's the first line. That's I is equal to 16N. But what about her costs? Her costs are 8N plus 24. Okay, so 24 is about here, halfway. So if she sold, maybe it's best to do a table of values. Okay, so N and C, 0 and 1. If she sold nothing, her cost will be 0 plus 24, which is 24. If she sold 1 book, 8 times 1 is 8. It's going to cost her 32. Okay, and so now that we've got those two, we will be able to draw a straight line, and it will pass through here, which means that the break-even point is 3. She needs to sell 3 books in order to break even, to not make a profit or a loss. Alright, last question. I'll get you to pause the video, have a go with this one yourselves. You will need to try and write an equation for each of these, and then draw the graph. I would probably solve it algebraically to work out what the break-even point is first, and then I will graph it. Okay, so a factory produces items whose costs are $1,000 plus $10 for every item. The factory receives $60 for every item sold. So cost. All of this has to do with cost. So we're only looking at those numbers. The cost is equal to 1,000 plus $10 for every item sold. So 10 times N or 10N. All of this is income. Okay, the factory receives $60 for every item sold. So that means the income earned is equal to 60 times the number of goods sold. So now we're going to graph this. I want to know how big my graph needs to be. So all I'm going to say for part B, I'm going to just work out the break-even point by saying income has to equal to cost. Well, if income is 60N and cost is 1,000 plus 10N, okay, and I got that from here, from the questions before, then I can subtract 10N from both sides. 50N is equal to 1,000. Divide both sides by 50. So N should equal to 20. Okay, well, if the number of items is 20, how much income will she have earned? Well, because income is 60N, we've got 60 times 20, which is 1,200. So that informs us how high up to go for the y-axis. Alright, so number of items. I'm just going to put dollars here for income and cost. And because here N is 20, I might go up by 5s. And because here income or cost is 1200 when n is 20. I'm just going to go up by, let's go up by 200. Actually, let's go up by 400. 0, 400, 800, 1200, 1600. Okay. So, let's sketch the income one first. 0, 0. Let's do it like this. And then I, 0 and 1. If none of them were sold, no income. If one of them was sold, income would be 60 times 1, $60. Okay, or better yet, right? Because we've done 5 and 10, because that's how I've labeled it, let's just do 10. If 10 was sold, income would be 60 times 10, which is 600. So 10, 600, about there. And just draw a straight line. Okay. What about cost? We'll use 0 and we can use 10 again. If n was 0, cost would be 1000 plus 0, which is just 1000. And if 10 was sold, it would be 10 times 10, which is 100. 1000 plus 100 is 1100. Let's do that in orange. 0, 1000, right here. 10, 1100, about there. Okay, so when we sketch our straight line, it's going to go through this point right here. And it'll tell us that the break-even point is 20. Okay. So, homework is exercise 5E, question 1 to 7 on page 215 to 216, and it's due on Tuesday next week. If you have any questions, just email me. And that's it for this video.